The LG Procast, the podcast, is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation. The information provided in this podcast episode is for informational purposes only and does not constitute professional advice. While we strive to provide accurate and up-to-date information, we make no representation or warranties of any kind, express or implied, about the completeness, accuracy, reliability, or suitability of the information for any specific application in the following discussion. LG and those posting or otherwise providing information, content, or material are not responsible or liable for any consequences relating directly or indirectly to any action or inaction you take based on the information, content, or other material on the podcast.
Hey guys, welcome back to the LG Procast. I'm Philip Craigbaum, joined with Mr. Terry Frisenda.
Good morning. Hey, here we are again at Elevate 2025, an LG event. We're on day 2.5, I think. It's early Saturday morning when we're filming this, so thanks. We want to talk to you about a pretty new development from us, for us, and really for you, for the contractor base out there, and it's the LG CAC Partner app. And, you know, Philip probably single-handedly had all the input for this app development. And man, we're just going to, get into it. It is a great tool. So why don't you tell us a little bit about the app, and then I got a ton of questions about it.
So this was a little bit of a brainchild of mine with input from guys in the field and, a lot of questions that I got. And one of the pain points that we've always had is we give a ton of information, and sometimes that's almost a problem because there's so much information. Guys don't know, or they don't want to go through an 800-page document to find the data that they're looking for. So I was like, why can't we build an app that just calculates some of these things for them and put it out there? And then, so basically I wrote what I wanted it to do. And then our engineering team from the US and from the Korean team took it and they built this app, and it's fantastic. Really, I think it's super useful. If I were out in the field, and when I get calls from contractors, I'm opening it all the time. And so we'll kind of, it does three things.
Okay.
So the first thing is a capacity calculator. So everybody wants to know, what does my machine actually have the potential to do in my climate? Because as you know, heat pumps don't perform the same in all climates. The heating output in Orlando, where we're at today, is not going to be the same as it is in Minnesota when it's negative 10 degrees or whatever it is. And so we've always had these data tables that you can go and find that information, but it's not the easiest thing to access. And so we put together a capacity calculator, a static pressure chart as well, because some of our ducted products, the mid-static and some of our unitary style air handlers, you have to go in and set the static pressure. You set the fan speed technically for the static pressure that you have. And again, you got to go in and find the data table. So we've made that information more useful or easier to find rather. And then the charge calculator. So you put in your pipe lengths, what piece of equipment you have, and it will tell you what your trim charge is going to be. When you get into the larger multi-zone systems, especially when you're using branch boxes, so you've got larger main pipes and then you've got branch pipes, well, this allows you to just put in the data. How long is your main pipe? How long are all your branches put together? And then it'll tell you how much refrigerant you need to add to that system.
So I know, we have a class that many of our sales guys used across the country, PWC, piping, wiring, and charging. And that's something that I worked on years and years ago. And then all these guys that are young and smart have taken it and improved it and made it better. But the basic information in that PWC class is really what you've kind of incorporated from the installation side. That's kind of what you've incorporated here, is what I'm hearing. So now I can see performance.
Yep.
I can see those fan curves that I need to set, right, when I need to set them. And then, of utmost importance, clearly, is that refrigerant charge calculator. Putting that information in front of the guy's hands and easily accessible, because it's all about the refrigerant charge in these systems. It's got to be correct. That's why it's called critical charge refrigerant systems.
Yep.
So it has to be correct.
Yeah, I've heard some very dangerous comments from contractors over the years. We always just put in about a pound, or we put in about a half pound, and we call it good. And it's got an accumulator, so we don't really worry about it. And I'm just like beating my head against the wall and wonder, why do your systems not work? And when everybody else's who do it right don't have performance issues. But yeah, I wanted to create something that because that's where I live. I live in the design side all the way up to installation. I tell guys all the time, like, once you put it in and once you turn it on, I'm not the guy to call. I'm not the troubleshooter. I'm not the one that's going to help you figure out why it's not doing this or why it's doing that. That's just not where my expertise is. But, designing systems is probably one of the most important things, in my opinion, is designing it right.
Well, Philip and I work together on a team that we call affectionately like our paycheck or our official title, or builder sales or something like that. But, really we're trying to get an acronym, and we're trying to get a name, and we're trying to get known as the ADS team or ADS team, which is application and design specialists, right? Because that's really what we do. Because we understand and we realize that if we apply this product correctly, right, and we design this product correctly, and we install this product correctly, it does exactly what it was engineered to do, and that is provide comfort in homes and businesses.
So I have a question I want you to answer, because the capacity calculator is important. It will give you the rated outputs and the maximum outputs, both heating and cooling for your project based on your indoor temperatures, your outdoor temperatures. Talk to everybody about system design, sizing. How do you size a system? Do you size it off rated? Do you size it off maximum? Do you use both? How are you using those numbers?
Great question. Let's start with probably the definitions. Okay.
Perfect.
So you got rated and minimum capacity and maximum capacity. Understanding that we have and sell an inverter driven Hertz changing compressor.
Mm-hmm.
All right. So if you think about that just for a second. So the rated capacity that you see is the same thing that you've seen from legacy manufacturers, right? This 3-ton system makes this much heating and cooling. Okay. So that's rated capacity, and that's what we've been using to design and apply for manual J's and things like that through the years, all right? Having a Hertz changing compressor allows us also to see what is the minimum capacity. In other words, how slow or how low can the Hertz go on this compressor to meet capacity? And then the maximum is just the polar opposite of that. How fast can this compressor spin? And how much heat or cooling can it make when it's spinning at those speeds? Listen, I just explained to you the entire magic, if that's what you want to call it, with what inverter-driven Hertz-changing compressors do, something that every HVAC contractor has asked for since the dawn of time, and that's a compressor, a system, that can change its capacity based off the weather, based off the thermostat setting or controller setting or whatever you call it. That's what this technology brings you.
So if I hear you, rated is not full speed.
No.
Rated is a part load, and it's just a speed that the engineers use to go get our ratings, our AHRI ratings, our SEER ratings, our COP, HSPF, all that. That's all based off of that rated compressor speed.
Absolutely.
So it's going to be, in that ballpark of 60-ish hertz.
Somewhere.
It doesn't mean it's exactly at 60 hertz. That's the speed. And that's part of one of the beauties of being an inverter is they allow us to choose that speed, that part load. So if we need a little more SEER or a little more of this, you can slow your compressor down and you sacrifice capacity and all that kind of thing. So it's a baseline. It's a starting point. Would you call it a starting point in design?
Certainly call it a starting point in design. And as a general rule, in the manual J software that's been used forever, which is a wonderful tool, which is, we can't say it enough. If you're a contractor and you're listening and watching this, if you're not using manual J, please do us a favor and start using it. All right. 100%. Because it's that important, because we're managing BTUs, right. And creating BTUs, and we want to manage those, particularly when we start zoning stuff like what Philip talked about with having a multiple zone indoor unit system. You have to know the BTUs that you're addressing, and then you're selecting evaporators that meet those BTUs in a rated condition, right? That's how you design and apply these systems correctly. You still have to size properly.
Yeah.
Because to take advantage of that Hertz changing, the system has to be designed to run. And if it's oversized, it's not going to run as much as it needs to be. And if it's undersized, it's going to run more. So that all stays the same as it always is. But I want that rated design to be in there so that I can take advantage of this Hertz operation, right? Because literally manual J is probably oversized 30% of the time, maybe higher.
Yeah.
Depends on who you talk
There's
to.
already wiggle room built in.
There's already wiggle room built in. So you're already pushing the envelope for having systems that are on the edge of being, I don't use the word oversized, but they're at the top end of their selection, if you will. And now you have the capability to say, okay, let's dial this in, let's tighten this up, and let's get a system that performs more accurately, more efficiently along this.
On manual J, even in the book, in the manual, it states that it is preferred to be undersized over oversized. I mean, within reason, right? I mean, slightly undersized. I remember years ago in my career, I was at a training class from another manufacturer sitting there, and they said, take your manual J, look at the minimum, look at the maximum. As long as your load falls in that window, you're good to use this piece of equipment. And I was like, oh, that's pretty nifty. That's pretty neat. I cannot believe how far from the truth that statement is.
There's a lot.
It does not work that way.
No, it does not work that way. And you know, oversizing, it has just plagued our industry. You know, bigger is not better when it comes to HVAC, you know, selecting the right piece of equipment.
Even with inverters. And I've seen this and I've seen it and I've seen it where if you put in too large of a system, what it does is it'll get to the temperature that you need, but it does it with not a very, very cold coil. And so if you're just trying to maintain a 70-degree home and you have a very large system, you might be doing it with a 60 or 62-degree coil. And guess what? If that's not below dew point or not really below dew point, you're hardly removing any moisture. So yeah, even though you're in that window, you still need to be sized properly. And that's why Manual S does not say, oh, if it's an inverter, you can be as oversized as you want. It allows maximum of 30% oversize on the cooling
for an inverter.
And that's pushing it.
Right.
You know, I personally wouldn't want to be that far oversized in most scenarios, but it is technically legally allowable, but it doesn't just say slap it into any size system you want.
And again, that's one of the things that's plagued this technology from the early start. It's been addressed. So yeah.
And I think it's more on the heating side, the difference between rated and maximum, especially on our red equipment, you know, so I tell guys, you know, look at the rated capacity, but then look at the max, because there's on our red equipment, sometimes it can be a difference from it's rated at 24,000 BTUs, but can actually do 40 something thousand BTUs. So I'm probably not going to design directly at either one of those numbers. I want to be using my rated as kind of a base point, but I also need to know what that maximum can do. Because if I've got a heat load of 30,000 BTUs, it's rated for 26, 24, but it can do 40. To me, that's a pretty well-sized system on the heating side. I probably don't want to go up another size just to get that.
Yeah, because then you run the risk.
Agree?
Absolutely, because then you run the risk of having a system that's grossly oversized in the cooling mode, and that creates the problems that we've been talking about. You know, your analogy and your messaging when you're in front of your builders and developers, and we're talking to those folks, your message of let's look at that maximum performance, and even though we may not require an electric heat kit, putting an electric heat kit in to run some of those extreme days makes better sense than having an oversized unit all the time in the cooling mode.
Can I chase a little rabbit trail on the heat kits?
Absolutely.
So here's what I want all of our people to understand. When you're putting in an LG unitary system, we offer heat kits. The way that we need to calculate a heat kit size is you need to look at your manual J heat, and then you need to look at the heating capabilities of your unit, and whatever that difference is, that is what you use to calculate your heat strip.
So that's the size of heat kit that you're buying.
Yeah, so every watt gives you 3.41 BTUs.
That's right.
So you do that math and you figure out, okay, if I've got a heating load of, I'll call it 40, and my machine can put out 35, my heat kit only needs to be large enough to make that 5,000 BTU difference. So guys that are putting in 10 and 15 and 20 kW heat strips, and I do understand there are cases and scenarios, but in most cases, that's really not the scenario. You're more likely to have a power outage than you are to actually lose your compressor. So in most scenarios, you're needing 3 kW strips, 5 kW strips, which is a whole lot less power. And the cool thing is when they come on, they supplement the compressor. And so
they run with the compressor.
They run with the compressor, and they only run when the compressor really, really can't keep up. So instead of having your system shut off the compressor and flipping over to a 15 kW heat strip, now you're pulling, I forget what the numbers was. I did the math on one of our presentations. It was like 70 something amps. Well, the compressor plus a 3 kW heat strip is like half. It was like 36, if I'm remembering my numbers right. So even when our heat strips are running, we're pulling a lot less power.
So you just heard a perfect example of our acronym ADS that I've created. So the application design specialist. So we're adding this team of 4 that we have in the country. That's the value add that we're bringing to this builder community, to the contractor community. We can sit and have these discussions and explain this from an application perspective and from a tool turning perspective, because that's the team that we have together. That's how we grew up, and that's how we manage our business, and that's how those are the messages that we want to push forward. It can be done differently. Let's look at what we can do. Because I got to tell you, in a 200 home subdivision or 300 home subdivision, which you and I talk to these builders all the time, if I can change from using a 15 amp breaker in a home to a 5 amp breaker, that's a ton of power that's not required for that neighborhood. That means some infrastructure changed, right?
When you're doing a large scale.
Yeah, transformers changed, undergrounds changed, the feeds from the power company changed. There's a lot of money saved there that far outweigh any HVAC costs.
Last year, we did an apartment building. It was originally designed for unitary equipment. With the 410A change, that unitary manufacturer was not able to provide the equipment that they needed. They'd already wired the building that way. But when we did the math and we calculated it, there were 2 buildings, and each building had over 5,000 amps saved.
How many apartments was a building? Do you remember?
I don't.
It doesn't matter.
It was a fairly large apartment.
5,000 amps is a lot of power.
Per building.
Per building.
So had we had the opportunity to come in the beginning of the project, do all 6 buildings, take 5,000 amps out of all 6 buildings, that's 30,000 amps that we would have removed from that complex. So to your point, that savings starts multiplying, because now we're running smaller feed wire, smaller transformers. Absolutely. We're getting less power. The utility company has to bring less power into the complex. So now as the developer, there's some massive savings for, oh, well, golly, the inverter cost a little bit more than what I've been using for years and years. Well, yes and no.
Right.
The boxes cost a little bit more, but when you look at the project, good gracious, there are some amazing savings. And then on top of it, our utilities team came in and found a couple $100,000 in rebates from the utility company.
Yeah, the utility companies willing to give because they understand the savings associated.
And the developer, the builder, had no idea that was available. Here you go.
Back to the developer.
Yeah, and they had no idea it was coming.
There's ads at work right there.
Yeah.
Okay, there's ads at work for you right there.
It was a great project. This team and this job is I mean, I've had great teams here at LG, but this is a lot of fun. You, Charlie, Ken Sammons, me.
No, we're having a ball. I mean, and some of the stuff that's gone on in this meeting this week, we had the opportunity to have a session, which you probably will see before you see this session with the group and questions and stuff. But being asked a question yesterday when I was on stage, and what do you feel about? How do you feel about the future of LG? Well, I think you see and hear from Philip and I sitting here in front of you how we feel and see about the future of LG.
Yeah.
I mean, the commitment from LG Manufacturing, the commitment from the Korean leadership, the commitment from our American leadership. This is an exciting time to be here. I almost wish I wasn't at the end of my working career, so that I could take longer part in this fun. I kind of wish, that I would have done this 35 years ago but it wasn't available.
And it's so much fun. And we had this conversation yesterday. We were talking to Tersh and Josh, technology in general over our lifetimes, I'm an 80s child. And so technology was starting to take off, but in the last 10 to 15 years, that curve, the rate
Nope,
of
this is crazy.
change, with AI coming out and just so many different things are changing, and our industry is following along. There's a lot of changes happening, the technology that's going in, AI coming in, controlling your systems from your phone, but also just the inverters and what that's done, and the cold climate.
If you look at that LG CAC partner app, like you said, man, there's stuff built in there. There were some questions asked this morning about, hey, can we kind of help bring a couple of apps together and things like that, so that we're not working with 3 or 4 different things. And I think that was a great suggestion. I believe the team is already working on trying to.
Yeah, there are several apps. There's a service app. There's one for our LG Pro dealers. There's one that now that has the partner app for the design tools, and it's not as simple as it sounds. There's different teams, different engineering teams that own each one of the apps. So yeah, there's 3 or 4 that you need to have on your phone. The LGMV, that's the other one. Yes, we are working on trying to incorporate some of those together, but at this point, I think there's about 4 that they need to have for different points of the who needs it, the designer or the technician or anything like that. But talk about fan speeds for a little bit, because it's got the static pressure settings in there. Walk us through how to maybe even go as simple as, how do they test static pressure? Because I think that's one of those things that is not as well known as it probably should be by technicians. And then what happens if you don't set this fan speed, and then maybe quickly how to set the fan speed.
So external static pressure, ESP settings, those are airflow measurements. So ductwork that's undersized, ductwork that's oversized, return airs that are too small, and they create a myriad of operations. It's not just like poor comfort; it's mechanical related. It causes, high pressure head pressures for compressors, and a dirty filter creates, it's like trying to blow air through a little bitty balloon that you're trying to blow up, and you're like, I can't blow it up, right? Well, think of as the compressor outside trying to work because the air's clogged up, right? So having that blower will be able to move air that's designed to be in that duct system, right? That's designed to cool and comfort or heat that place is critical, right? And several of our products require, and most products require, that you first test and measure, right? And there's a process for that, and there's tools for that. This is probably not the venue for that, but there is, all right? And then once you test and measure, then you go set.
Yep.
And establish those fan curves, those fan settings that produce that required or that needed or that designed pressure, so that air is getting distributed through that ductwork appropriately in each room. And here's a perfect example of how you know your static's messed up, right? Poor duct design and an air that's not coming out of one of your registers, right? Or 2 of your registers at the end of a duct run or things like that. That's because probably poor duct design and static pressure wasn't properly set. All right, so if you're designing and you're doing static pressure correctly, then you have a system that's going to deliver, right, the correct amount of air, and the mechanics are going to work better, the air is going to work better. So you set those fan curves, they manage it accordingly. One of the things about this technology, and I had a question this week, during this event, asking about the variable speed indoor fan motors, all right? We all use low, medium, and high, all right? And the ECM motor that we use, or the BLDC motor that we use, keep a constant torque, constant output based off that design static pressure. So that's why it's so important to set that. The beauty of the ECM motor is it does it automatically for you.
Yeah, I like the ones that have the ECM motor.
Right. So, but if I have that BLDC motor, you physically have to go in through the controller and establish those set points for low, medium, and high output to match your design static pressure that you measured and recorded with your instruments and tools. And then you'll have a system that will work properly.
And I've gotten the question a lot, and we're still pushing engineering for it. Why don't all of our equipment have the ECM motors? And I was finally given the answer not too long ago, and it's just a physical space size. The ECM module on the side of the motor is large, and it physically doesn't fit in the cabinet sizes. So we're telling engineering, we want smaller cabinet sizes, but we want you to put the ECM in there. And they're going,
We want it all.
do you want A or B? You can have A or you can have B. So obviously we are working on doing A and B through some really smart engineers, but that's why some of our units have not gone to the ECM motor, because it physically will not fit the module on there. But I'll tell you a quick story. Years ago, when I was pretty new in my HVAC career, we put in a 17-SEER, 2-stage, reputable brand piece of equipment from a legacy manufacturer. And in 3 months, we lost 2 compressors. I mean, first one went out. Oh man, that stinks. So we went out, we changed it. Second time it goes out, we're like, wait a second, this is not right. Customer not real happy with us. Spent quite a bit of money on it. And it all had to do with coming out of the unit, coming out of the plenum. There was a very harsh transition, and we failed. And I didn't know any better at the time. We didn't test the static pressure. We didn't set it right. So it was not delivering enough airflow. And I had no idea that airflow could kill a compressor. And it absolutely was, because what was happening is we had too low of air. So we were not boiling off all the refrigerant. And so then you send liquid refrigerant instead of in a gas state. We were sending liquid refrigerant back to the compressor, washing all the oil off the compressor, and then wondering why the compressors failed.
They're designed to pump. They're not designed to pump liquid.
It was not. Yeah, it was not a bad compressor design, but we were killing it because of airflow. And I think airflow is such a underappreciated part of this industry. They all just want to look at the equipment, and the equipment in X13 ECM motors have gotten a bad rap in the industry. Now, one thing I appreciate about the LG equipment is there's a lot of safeties built in. Yeah. And I think you were probably involved in this job years ago, but we had a piece of equipment that they could not figure out why the compressor refused to ramp up past about 40 or 45 hertz. And we would hook up our tools to it, and we were just like, this compressor will not ramp up. It will not ramp up. Well, come to find out that it was a low static system, that nobody had ever set the static pressure, but the ductwork was way too restrictive.
My way to kind of explain that, guy, is listen, here's the logic how this stuff works, okay? I'm the system, I'm the box. I'm going to protect my heart, the compressor.
Yep.
I'm going to try to make cooling. That's logic number 2. Or I'm going to try to make heating, logic number 2. But guess what? Logic number 1 is I'm going to protect my heart. All right. And so that's a way to tell this contractor base,
right,
this is what we're doing, guys. This is why it doesn't work.
Yep.
Right. So, well, man, I've had a ball.
Yeah.
It's been a great week.
It's been an awesome week. So if you guys don't have it, it's the CAC Partner app.
Right.
What is CAC? Commercial Air Conditioning?
Commercial air conditioning.
That's one of the LG acronyms. We love our acronyms.
We love
LG.
them. We love
CAC Partner app. You can get it in the Play Store. You can get it in the App Store or whatever. This is a global app that's used throughout the entire world. It was developed by our team in Korea. So make sure that when you open the app, you scroll all the way down to USA. Because if you go to Germany or you go to Turkey or India or whatever else is listed in there, it's not going to give you the tools that you're looking for. So USA is at the very bottom. Scroll all the way down, click USA, and then you'll have those 3 tools right there at your hands. Terry, thanks for joining me.
Until then.
Appreciate it. And everybody out there, thanks for joining us. And we will see you next time on the LG Procast.